Hello, future programmers. Welcome back to Zero to Hero series. This is episode 3 of part 1. And today we're talking about something that's small but can save you from total chaos in your robot programming journey. We're going to talk about Enums. Yes, not the Pokemon. Though honestly, that kind of would have been cooler. I choose you, Inumachu. Wait, is it I choose you, Inumachu? Okay, me. I think I'm embarrassing myself. I don't know. When I was a child, I used to watch Pokemon, and I love the character. Um, okay, let's stop embarrassing myself, and let's continue this. So by the end of this part, you will see why enums are basically the secret sauce that keeps your code readable, safe, and a little, ever so slightly easier to debug. Coding is always, reading code is always a pain in the ass, but at least this will help you reduce that ever so slightly. Okay, so let's start with the classic rookie move using plain numbers for states. Something like this, right? Yep, it runs. It's totally fine until it's not. Because in this way, nothing stops from someone to enter a different state, entering a different number, right? So you have all your states: red, green, and blue. You can totally say set motor state to red, green, or blue, but nothing stops from someone else to change it to a different number, right? And you wouldn't really notice it until the robot kind of starts to do something weird. At that point, it's kind of too late. I mean, it also depends on the context, but kind of is too late when you started deploying it, and you know. But in a way, your in a way, if you try to pass something that doesn't exist, like colored or purple, the compiler literally won't let you. It is like Java giving you a side eye and saying nope, not today, right? It's much more simple, clear, and safe for people to see, and just for programming language to process it. Okay, so this is why enum is basically created. Um, so why do we even bother with enum? Because it's not really that different from what we do right now. We can still do everything we do in enum in if and else statements, right? But there's a reason why we use enum. Uh, you can't accidentally pass a weird value, right? So it's also a bit more readable. It explains itself way better than just saying 1 or 0, right? And all your related constants live together, no more scattering them elsewhere, right? You kind of organize them by class. It's neat. Enums can also have variables, constructors, and methods. Yes, we will talk about this later in episode 2 or 3. So, let's actually show you why exactly they are safe. I don't think this is enough for you to know why it's safe. So let's actually kind of do that real quick. So I have a main function. So it's your normal. I added my public static final red, and these are my states. Okay. Uh, right now these are not technically my states, but consider them as a state. Okay. Red meaning the motor stops. Green meaning the motor goes in 100% speed. Blue meaning the motor goes in 200% speed. Okay. I just made a function real quick. It takes an integer state and then just prints it out. Okay. So this works, right? I can do this, right? Instead of red, I can say stop, right? That's a state, and then motor state stop will basically make the motor state 0, which means it's gonna stop, right? If I run this, run. Okay, that wait, please run. Oh, it's running. Okay, you know, Java does take a little bit time for it to complete. even the slightest things. But it's okay. It's okay. We got this. We got this. So set motor state stop kind of works, right? This works, but what if I'm someone who's trying to like make sure your robot doesn't function? What if I set motor to like unnamed state? Because these are already known values. You would actually simulate it in like different simulations, try it yourself in your dev mode, and then get your values. What if I, being your malware guy, I could just have a different number, right? I mean, as long as it's a number, right? It'll still take in. Maybe okay, maybe not. Integer has a limit. Okay, that's the limit, right? Integer can only take up to 10 digits. Other than that, it can't. It's too long. Okay. So if I run this, this is also gonna run. Obviously, it's gonna take a while because Java compiles it, builds it, and then runs the code. But you see, I made the motor state to this number. I don't really have any protections against it, right? But if I change it to enums, where I define each enum, actually, let me just show you how easy creating enum is. Okay. Okay. So obviously, to create the enum, you say public. Does it have to be static? Not really, but you can make it static if needed. You can just say enum, and then my enum name is color because red, green, blue are colors. And then I could basically I just have to list it: red, right, blue, uh, green. Okay, and then I stop it using my semicolon. That's basically all I need to do, right? So set motor color.red, color.blue, and then blah blah blah. Okay. Now let's just say I'm the same malware guy, and then I say set motor, and then I give a color or a number that isn't there. So let me try a number, 14, and then let's run this. Oh, my code, my ID already said that's not a thing, right? And let's actually see this. It's parsing, it's building. Now, here's the difference here, right? This code did not even deploy. It did not run. It was in the build state, build output. So which means if you use enums and that's how your robot code works, you would know if this code works in the robot before deploying it because it would never build. If it fails to build, then you know you messed up something. So it's much more safer for you to use enums. So that's kind of the definition. And also, what if I just use color? Okay, color dot, give me a random color, yellow. That sounds like good. Well, it doesn't work, right? Because I never really listed it, so it kind of yells at me. Yes, my ID is kind of very mean, but that also makes it more safe. Okay, so that's the reason why we use enums. That's one of the main reasons why we use enums. But let's go to our module 2. Enums are full classes. As I said in this slide, they are expandable. You can create methods, you can create constructors, you can create a lot of all these classes. These are full classes, okay? So they aren't just lists of words, they're just full classes. That's basically what I said. Each value inside an enum is basically an object. That means you can give it data, methods, and whatever you want. Now, each state carries its own number. No more random if statements to figure out what the value should be. Clean, simple, and impossible to accidentally mess up. So let's actually create our own enum class. Okay, so I'm just gonna reuse this. Yeah, I'm gonna reuse this. Actually, let's just complete the slide and then we'll come back. So now we know enums could be a class, kind of like this. Okay, you have all your enum list, and then that's your class. Signal strength double power is your constructor. Okay, so it's gonna construct this object for each and every single item in your list. Okay, so low is an object, medium is an object, high is an object. But how do I actually make it safe? Okay, and why is this safe? So here I have some other examples here. So I have this function, so public static void tune double power. Okay, so tune accepts it, and then 25.0 is also accepted, negative 19.0 is also accepted. You can literally type anything and the compiler has no protection whatsoever. But if you use a enum, now this is protected, right? It wouldn't really compile 0.9 because you are only requiring signal strength. That's your class type, right? That's your enum class. You're only accepting enum types, enum items that are in the specific class. So, and also signal strength dot super high. Super high is not one of our objects, so it's never created, so it'll have a problem. Okay, so how do we connect that to our FRC machines? Okay, in FRC, robots are always in one state at every single time. Intake might be in, out, or stopped, or elevator might be low, mid, or height. I mean, I said moving up, staying still, or moving down. Your robot is never doing everything at once. That's the key core concept of why state machines is even a thing, right? Enums are perfect for this. Part 2 is where we actually take these enums and plug them straight into real world systems, so you can see them in action. For now, we'll try to replace your magic numbers with enums in small test program. So let's actually start making this amazing function. So let me think. We'll basically try to create our own elevator function. You know, let's try to create this. Okay. So I'm gonna it's fine. I don't want to change it. Actually, I want to change it. I'll create a new Java class. It's gonna be elevator Java. Okay. I don't need that. I don't need that. Please move away. Okay. So in our elevator, you would have basically let's have four states. Okay. So let's actually make a class. So enum class. Public. You don't have to make it public. I just like to make couple stuff public. This needs to be public. I'll tell you why later. But public enum states. Okay, or elevator states. Elevator states. Okay, so let's define our states. One of our state is being low or to the ground, right? And then let's do some L1s. L1s is our state, L2 is our state, and then barge is another one of our states. So those are our states, and then we'll make a function. So public, and then go to public void go to state. Okay, and then I will ask for the elevator state. So elevator state, and then I can define it whatever temporary variable I want. Okay, and then let's just say that print or stop. No, is it SOPT? No. Yes, SOUT, south. Okay, and then let's just say going to state. So let's also make a main function. So public void, no, public static void main. Okay, and then I'm just gonna say go to state, and then I'm gonna give it my elevator state. So I can say elevator state dot L1, right? If I run this, I hope that it prints me going to, and then going to L1. It has a problem. The reason why it has a problem is because this is a static method, so it wants this function to be static too. Remember, static is basically running in a different universe. Basically, uh, it has static and non-static. Those are separate different systems. So if you want to run something in static, you want to have something, you want to have a method in static. So this will run. Let's run this. Obviously it takes time to build for the first time, and going to L1. Okay, if I just change it to something L2 or barge, right, it's gonna print going to barge. Let's hope it goes to barge. Yeah, going to barge. Now if I do L3, then obviously it's not in my list, so it wouldn't do anything. Let's actually run this. And then it's gonna say build output. Yeah, build output doesn't have a thing. It's not a thing. L3 is not a thing. So that makes it kind of easier, but that's not enough for us. We'll actually make it a function. Okay, let's give it some height. Okay, so let's actually make it a private variable. Remember, we're basically creating a class. So private double and then height. Okay, and then let's make a constructor. So constructor is quite simple. It's just public and then your class type, which is your elevator state. So elevator state, and then this is where you could give some very amazing properties or definitions for each one of these items. Since we're talking about elevator state, I think talking about height is kind of important. So for ground, the height might be just 0, right? 0 inches off the ground. L1, let's make it like 10 inches off the ground. L2, let's make it 30 inches out. And then barge, let's make it 67 inches off the ground. And I like to make it into a vertical list rather than horizontal. It's just, I don't know, my eyes likes it better in this way. And it has some errors because you never really asked for a number. So let's just add a number. So double, let's make it a double. Yeah, sure, why not? Double and then height. If I do that, it solves most of the information. And then I can make it height is equal to height, basically defining this placeholder value. Once I do that, wait, what's the problem? Modifier public not allowed here. Make elevator states not public. Well, I guess that's fine. Yeah, sure. It just deleted public, but okay, whatever. And then I can also create a method like public double get height, right? And then this is just gonna return my height. Return height. Okay. Now using this defined variable, what I can say is elevator state dot, let's do L3, L2 actually, okay? And then obviously this runs as you think you would. It's just gonna say L2, L2. But also I can get its height. Since L2's height as defined is 30, and then we are basically pasting that into our height, and then if I run get height, it's gonna return that specific height. if I say state dot get height, I hope it's gonna return 30. Going to 30. Let's see. Come on, you got it. Got it. Okay, going to 30. Right. So using this specific concept, what you can do is instead of go to state, you can run some PIDs, right? If I say elevator dot state L2, then using your PID, get its height, get your current height, and use PID to go to that specific height. Yeah, that works. Yeah. So this is the core concept of having um, a state machine code. Okay. Uh, it's actually kind of late for me. Thank you for listening or for my yap session. I do it every now and then. Let me know if you have any questions. I can try to answer it. But yeah, thank you. This is 21 minutes. Oh, dang. I actually thought this would take 15 minutes. But alright, see you guys later.